Hi students, now in this third video of this chapter, that is magnified electric current, we come to the new concept, another important concept of this chapter is solenoid. Okay, now let us start the new term. If it is here is solenoid. So here same concept, solenoid is a device which is produce a magnetic field, and how it produces a magnetic field, same concept is with help of electricity. So in this chapter, somewhere we use electricity to produce a magnetic field, and sometimes we use, in the next video, we use magnetic field to produce electric current. So it is vice versa, relationship between current and magnetic field. So let us start this concept with some points. That is first about diagram, how the solenoid look like, and with help of diagram we define the definition of solenoid, and then later on we find the how the magnetic field, which forms of the magnetic field is present inside the solenoid, where current is flow through it, and the last the use of the solenoid. Right. So let us start one by one with the diagram. Okay, the diagram of the solenoid. Right. So here how the solenoid is look like. So solenoid nothing but in the form of a cylinder. Right. Solenoid body means it is look like a exact in the form of cylinder like that. Okay, in the form of cylinder. So in which the insulated copper wire is wrapped on it like that. Okay, the insulated copper wire is wrapped on it. Okay, covered with silver closely. Okay, closely wrapped, closely. Okay, I make gap here, but actually it is closely wrapped. Right. So take a cylinder and in the form of cylinder. Okay, so take a cylindrical form tube and then wrap a insulated copper wire in the form of a cylinder. So we get like that diagram. So one term is connected to the positive terminal of the battery. Right, so this is the battery, and I can make here a switch for convenience. Okay, it is plug, and I can make here positive battery and negative terminal of the battery, or this is battery. Right, we know the symbol of this battery in the chapter of electricity. Okay, so next just attach to the second terminal of the solenoid. So now let us see, this is nothing but a solenoid. Okay, then label the diagram. This is the between nothing but what a insulated copper wire, and this is the S symbol, and this is N North pole. Okay, so here the solenoid is having two sides, two terminals. One terminal is called as north terminal, and one terminal is called as a south pole. Okay, north pole and south pole, exact like a bar magnet. Okay, it is behaves like a bar magnet. Right, so bar is the shape of cuboid, but this solenoid is the shape of a cylindrical shape. So that is difference, but they both having their terminals, one called north pole and one called is south pole. Okay, this is the solenoid. Now let us define the solenoid here. Right, so definition of solenoid. So see what we done here. We take a cylinder and we make a coil. Okay, number of turns is there. Okay, 100 turns, 200 number of turns are there. So n number of turns are there. So a coil, it is nothing but a coil. Okay, turns are nothing but a coil. A coil of many. Okay, there is many turns, maybe 100, 200. Okay, many turns of insulated copper wire. Okay, copper wire wrapped in the form of cylinder. Okay, I can make it closely wrapped. Okay, wire closely wrapped. I can add here number closely without any gap. Okay, closely wrapped in the form of cylinder. This is called as solenoid. Okay, so this is simple solenoid. We know the diagram. The diagram here in the form of cylinder. Okay, how we make the cylinder? So by closely wrapping the copper wire, so insulated copper wire in the form of cylinder, and this is nothing but what a solenoid. Okay, now let us next point. So about the magnetic field. Okay, because a magnetic field due to the current in the solenoid. Right, now let us pass the current to solenoid. So what happens? See, we know that conventional current is flow from positive terminal of the battery to the negative terminal of the battery like that. So current in the diagram is flow like that, from plus to the negative. So what happened whenever a current is flowing into the solenoid? What happened? The magnetic field is produced. So which type of magnetic field produced? It is exact same as bar magnet. So bar magnet can produce like that, same it is like that. Okay, a curved magnetic field is produced. Okay, curved magnetic field is produced like that. Upper and both side, upper and lower side, like that. Okay, I can make only two magnetic field here. I can make it 3. Okay, for convenience, I can make here 3. Okay, if more means we get confused. So I can take in 2 magnetic field here. There are number of magnetic fields are produced. Okay, I can, for understanding, we can take 2 magnetic field. Okay, like here the magnetic field is produced around the sunlight. Okay, so we know that it is a hollow cylinder. So here there are 3 areas in which the magnetic field is produced. One is upper side of the sunlight, one is lower side of the sunlight, and one is inside the sunlight, because the sunlight is hollow. How it is, see here? I can make the, see here, this pen is in the shape of this marker shape of the cylinder, and this is a insulated copper wire. I can wrap it. Okay, for understanding, see, I can wrap in the form of cylinder, closely wrap. Okay, see, observe here, and closely wrap here. Okay, I can closely wrap in the form of cylinder. So I can wrap here, small amount of turns are there. Okay, so this here, see that this is nothing but a sunlight. Okay, this one terminal, this one terminal current battery, and we observe that inside is a hollow cylinder is there. Okay, it is hollow. So what happened? If it is a sunlight, if a current is passed, means we observe that is above there is a 3 area. One above the sunlight, and one is below the sunlight, and one is inside the sunlight. So 3 area means 3 sides the magnetic field is produced by the current. Okay, so this is the sunlight. Okay, inside this field is there, outside the up and down is there. Okay, so this is, you observe here, it is hollow, means what, inside the area is there. But in the bar magnet, it is inside totally is solid, but it is a hollow, right? That is the difference. So here, see, we observe that by one current is passed through the, okay, when current I is passed through the sunlight, the magnetic field is produced above the sunlight, below the sunlight, around the sunlight, and inside the sunlight. Okay, so right here, current magnetic field is produced. Magnetic field is produced by the sunlight. By the sunlight when current passed through it. Passed through it. Okay, pass through it. So the magnetic field is from the form of, okay, the magnetic field form is what? The field form of magnetic field. Okay, magnetic field. So it is look like a, okay, how it is look like? It is look like a curved magnetic field. Okay, curved lines, exact like a bar magnet. So magnetic field produced outside. Okay, magnetic field, the form of magnetic field outside the sunlight. Outside the sunlight. Solenoid. It is in the form of core lines. See, outside the sunlight is in the form of core lines. Okay, they are not intersecting core lines. Okay, they are separate from each other. They are not intersect to each other. Okay, they are not intersect to each other. Right? That is the property of the magnetic lines. Okay, the magnetic field lines. They are never intersect to each other. So outside sunlight, we observe that the field is like a curved lines. But inside the sunlight, we observe that. Right, so here, see, I can draw the direction of magnetic field here. So actually the N means here, direction of magnetic field like that. Okay, so I can make here some mistakes. So from N pole to the S pole. Okay, that is the direction of magnetic field. Okay, N to the S. Right, means here magnetic field means it is from emerges from N and emerges from inside the S. Okay, that is the magnetic field. Okay, N to S. So that is magnetic field. So now let us see, outside the sunlight the magnetic field is curved lines, but observe that inside the sunlight the magnetic field is what? It is look like a parallel line. They are parallel lines, right? So magnetic field inside the sunlight is a parallel lines. That is we call it uniform magnetic field, right? So inside the sunlight, the magnetic field is uniform. Why? Because the magnetic field lines are parallel to each other. So they are parallel to each other. So example very important. What happened to the magnetic field inside the sunlight? So inside the sunlight the magnetic fields are uniform at every point, maybe here close to the sunlight, or maybe at the center of the sunlight, or any point of the sunlight, inside the sunlight, any point, maybe point A here, maybe point B here, maybe point C here, D point, every point is inside sunlight, any point, maybe closer to this cylinder, or maybe at the center of the cylinder. There is no Here every point, okay, every point inside sunlight the magnetic field is what? Same. Why? Because of the parallel magnetic field, because of the magnetic field is parallel. That is a very important point. So inside the sunlight and at every point of the sunlight the magnetic field is uniform, same strength of magnetic field is same inside sunlight, but outside it is different. Okay, when we move away from this sunlight it is decreases, when we come near to sunlight it is increase, because outside sunlight is very different there, but inside the sunlight the magnetic field is what? Same, uniform. Why? Because of the parallel. So inside the sunlight the magnetic field is uniform and there is same strength at all points inside sunlight. It is because of the field lines are parallel. That is very important point. So the magnetic field inside sunlight is uniform. Uniform, that is the every point inside sunlight has equal strength. Okay, equal strength, that is uniform magnetic field. It is because of the parallel lines. That is very important. Okay. Now this is the very important mean. There are some important terms about the magnetic field. Okay. Whenever a current is passed through the magnetic sunlight, there is a core field is produced outside sunlight, and the inside sunlight the magnetic field is produced, that is uniform, that is parallel lines. Okay, so please write down this point, and this point is very important. Okay, this point is very important. That is inside sunlight the magnetic field is uniform. Uniform means it is same. It is same at every point in the sunlight, same strength. So why? Because why uniform? Because of the field lines are parallel to each other. Okay, field lines are, they are straight parallel to each other. That is why the field is uniform at inside sunlight. Okay, but outside sunlight it is changing. Okay, so this is very important. Please write down this one. Okay, now come to the meaning. This is application of. Okay, so that is very important application of this field which is inside sunlight. So the field inside sunlight is very important because of the inside sunlight it is uniform magnetic field. Okay, strength of the field inside sunlight is same at every point. So this is used here. So use of the sunlight. Very important, use of the sunlight, application of the sunlight. So use, okay. So this is the uniform magnetic field inside sunlight is used to magnetize it. Okay, used to magnetize a soft iron piece. Soft iron piece. That is very important. Why we use a sunlight? So we sunlight is used. So the uniform magnetic field inside sunlight is used to magnetize a soft iron piece here. So what is mean? How we done it? It is so simple. We take a small iron piece. Okay, small iron piece, soft core iron piece, soft iron piece, and kept this iron piece inside this sunlight for a minute. Okay, we pass the current. So magnetic field is produced inside sunlight is a uniform same strength. So at that time we kept a small bar of a soft iron core inside the sunlight. Okay, so it absorbs this. It absorbs the magnetic field and it get what? Magnetized. Okay, and it is behaves like a magnet. Okay, it is get magnetized, and this soft iron core. Okay, the soft iron core when kept inside sunlight, it is absorb the magnetic field and then it is behaves like a magnet. Okay, it is behaves like a magnet. That is a magnetized iron core. Okay, how it is magnetized? By simple kept a soft iron core inside the uniform magnetic field inside the sunlight. So we get a magnet, and this, so the magnet produced by this process. Okay, whenever a soft iron core is kept inside the uniform magnetic field, it gets magnetized, and this magnet is called as electromagnet. Okay, electromagnet. That is very important. What is electromagnet? Simple definition: a soft iron core is kept inside a uniform magnetic field inside the sunlight, so it gets magnetized, and this magnetized iron core is called as an electromagnet. Okay, so please write down the definition of electromagnets. Okay, so why we use it? So use of this sunlight is to magnetize a piece of iron. Okay, how it is? A piece of iron is kept inside the sunlight, we get the electromagnet. Okay, so this is the use of the sunlight. So write down the meaning of the electromagnet. Okay, so I remove this one. So neatly write down this one. The notes here. So what is electromagnet and the use of both are here. So a strong, write down a strong magnetic field produce inside a solenoid can be used to magnetize, okay, to magnetize a piece of material, magnetic material, okay, a piece of magnetic material, for example like soft iron, okay, like a soft iron when placed, okay, condition is placed inside the solenoid, inside the coil or inside the solenoid. Why inside solenoid? Because of inside solenoid magnetic field is uniform, same strength. So inside solenoid the magnet so far is called an electro means current, so electromagnet. Without current we can make electromagnet. So that is very important point, students. So in this today's class we have learned a very important point about in the examination. Most of the time they ask the questions on this solenoid concept, okay. So first point you have to practice the diagram, and the second point you have to practice the meaning of the solenoid, and the third point we learn about which forms of the field is produced, okay. There are two types of forms of field is there. One is outside solenoid and one is inside the solenoid. Outside solenoid the magnetic field is curved lines like a bar magnet, and the inside the solenoid the magnetic field is parallel to each other. And the solenoid is behaves like a bar magnet. Why? Because of it having two poles, one is north pole and one is a south pole. It is a hollow cylinder, okay, it is a hollow cylinder. That is why inside solenoid is the magnetic field produced, okay. Then inside the solenoid the magnetic field is uniform. Why? Because of the field inside solenoid is parallel to each other. That is very important. So at every point in the solenoid the magnetic field strength is same, right? Write down the important point. Inside the solenoid, okay, inside the solenoid the strength of the magnetic field is same at every point, okay. Inside the solenoid the magnetic field is same, the strength of magnetic field is same at every point inside the solenoid. Why? Because of the uniform magnetic field due to the parallel magnetic field lines, okay. That is very important. And this uniform magnetic strength is used to form a electromagnets, okay. That is the process. So a strong field inside solenoid is produced with the help of current, is used to make and magnetize a soft iron material, that is for example a soft iron core, and that is nothing but electromagnets, okay. So that is very important point today we learn here. So same point, we use the current, we produce a magnetic field, and we use that magnetic field to produce an electromagnets. So hope you understand this concept solenoid. So in the examination they ask about define and explain about the solenoid, okay. Define the solenoid, draw the diagram of the solenoid and explain, okay. You have to explain all the first draw the diagram and then explain about it having N pole, it having S pole, and then it is in the form of cylinder, it is a hollow cylinder, right? It behaves like a bar magnet, and it is when a current is passed through solenoid it is producing magnetic field, yeah, okay. Outside magnetic field is a curved lines, inside the magnetic field is a uniform parallel. You have to explain all the points, and also you can write the use of the solenoid. So there are three types of question. One is define the solenoid with a diagram, or simple define the diagram, define the solenoid, and then explain the solenoid. You have to explain all these things, okay. It is how it is look like, okay, explain about the structure, and also you can use of the solenoid in the explanation. Or maybe they directly ask the question, what are the uses of the solenoid? So we have to simple write the solenoid is used to produce electromagnets, okay. How it is? So you have to write all this explanation. So this is very important, easy concept, okay, easy concept. So please again watch this video, repeat this video on the solenoid, because of very important concept, okay. Most of the time they ask the question on this, simple question is there, okay. So hope you understand this solenoid concept, okay, and you hope you can write in the examination when they ask about solenoid. So hope you are able to write in the examinations, okay. So please like this video. If you understand this one, like this video, share this video, and subscribe this channel. If you are new, means subscribe this channel, and in like that we have come to the next very important concepts of this chapter in the next videos. So in this video, so the solenoid concept is enough. So please write down all these points and practice it again and again, okay. So thank you for watching this video. Meet in the next video with a new important concepts, okay. Thank you again.